Hello. And welcome to another Chicago Bulls-like episode of Phillips Podcast, or P Squared. Giving a shout out to the boys in Chicago taking down the Miami Heat in Game 1 of the Eastern Conference Finals. Good luck tonight. Today's podcast is on Lesson 6.5, using the Pythagorean Theorem to solve real-life problems. By the end of this podcast, you should be able to solve real-life problems using the Pythagorean Theorem and rounding, as well as tell whether a given triangle is a right triangle. Vocabulary words for today's podcast. Remember, if you're looking for a leg or the hypotenuse, there is a difference. If you're looking for the hippo, he's going to add to your grocery bill. If you're looking for the hippo or the hypotenuse, you're going to have to add when you're doing the Pythagorean theorem. Remember that the Pythagorean theorem only works if the triangle is a right triangle. So for this triangle, in this triangle, the Pythagorean theorem would not work because they are not right triangles. Pythagorean theorem only works for a right triangle. Leg. If you're looking for the missing leg, you're going to have to subtract when doing the Pythagorean theorem. If you're looking for a missing leg, you're going to have to subtract when you're doing the Pythagorean theorem. The hypotenuse. The hypotenuse is diagonal from your right angle, and the hypotenuse is always the longest side on the triangle. Remember that by definition, you're going to use the variables a, b, and c when using the Pythagorean theorem. And the hypotenuse is always going to be the letter C. You may use A and B for the legs, or you may use the commutative property, plus 10 bears, off to a good start, and you may call this leg B and this leg A. But the hypotenuse always has to be the letter C. And I believe the last vocabulary word hiding somewhere is, there we go, the Pythagorean theorem. It's kind of like the Cubs, just takes a while to get going. The Pythagorean theorem, by definition, is a squared plus b squared equals c squared. Remember, c is always the hypotenuse. All right, so let's take a look at this problem. The recommended angle for a firefighting ladder is 75 degrees. When a 110-foot ladder is put up against a building at this angle, the base of the ladder is about 28 feet from the building. The base of the ladder is 8 feet above the ground. How high in the building will the ladder reach? Round your answer to the nearest tenth. All right, so for my visual people, here's my picture. I have a fire engine with a ladder that extends 110 feet. The base of the ladder is 8 feet above the building. So we're going to pretend that from the ground to the bottom of the ladder, the base of the ladder, it's 8 feet. They want us to know how long will this ladder extend going up the side of the building. Visual people, I'm going to draw a triangle. And it should be obvious that more specifically, this is a right triangle. Since it's a right triangle, there's a pretty good chance I'm going to be using the Pythagorean Theorem, which is, excellent job, plus 10 for your group, a squared plus b squared equals c squared. If you didn't remember the Pythagorean Theorem, shame on you, because you could have said, plus 10 for being resourceful. I'm just going to look on my reference sheet. All right, I'm going to go back up to the problem. It tells me the recommended angle for a firefighting ladder is 75 degrees. So this right here is 75 degrees. Here's my right angle. If they ask me for the missing angle, which they don't, but if they ask me for the missing angle, you could say for plus 10, take 75, add it to 90, subtract from 180, because there's always 180 degrees in a triangle. And I'd say, impressive. You must have had a very good math teacher. No comments from the peanut gallery. 110-foot ladder. So my hypotenuse is going to be 110 feet. Remember, your hypotenuse is always diagonal, your right angle. The base of the ladder is about 28 feet from the building. That's important to know, because that means the distance from here to here is 28 feet. I need to know that because that's going to be important, because now I know two sides of my right triangle. I can find the third side of my right triangle. So this is going to be a leg, and clearly this side is going to be a leg. Remember, Pythagorean theorem, your legs are always going to be A and B. So I can say A equals 28 feet, and I can call this B, or I can do the commutative property and say B is 28 feet. This leg is going to be A. I'm going to call this leg A, and I'm going to call this leg B. So I'm looking for the leg. Remember, I've got two choices when I'm doing the Pythagorean theorem. If I'm looking for a leg, I'm going to subtract. If I were looking for the hippo or the hypotenuse, I'm going to add. So I'm going to go back and look at the problem. It's clear I'm looking for a leg, so I know I'm going to have to subtract in the problem. So the first thing I'm going to do is I'm going to do 110 squared. If you tell me that that means 110 times 2, I'm going to say Miami Heat-like epic failure for you, because 110 squared means 110 times 110. Punch it in on your handy-dandy calculator. If you don't have a calculator, pause this podcast and go get one, and I'm going to minus 10 for your group for not being prepared. When I square it, that gives me 12,100. Next thing I'm going to do is square this leg. 28 squared. You didn't let me trick you this time. Plus 10 for your group, because 28 squared means 28 times 28, not 28 times 2. Good job. Plus 10 for your group. So that gives me 784. I'm looking for a leg. Since I'm looking for a leg, I'm going to subtract. So I'm going to take 12,100 right here, and I'm going to subtract 784. When I do that, it should give you an answer of 11,316. Remember, guys, I subtracted because I'm looking for a leg. If I were looking for the hypotenuse, I would have added here. Next thing I'm going to do, excellent job for your group, is I'm going to take the square root of 11,316. When I do that, the square root of 11,316, plus 10 for your group, because you recognize that this is an irrational number. Why is it irrational? Excellent job. Another plus 10 for your group, because when you square root it, it comes out with a decimal. It's not a perfect square. Excellent job. You're on a roll. That's plus 10 again, so that'd be 30. Hope you're keeping track, because I'm not. When I square root this irrational number, it gives me 106.37668. Now, I know that the distance from, visual people, the base of my ladder going along, or going up, I should say, the building is this right here. X is going to equal 106.37668. Now, they told me I could round my answer to the nearest tenth. So if I'm rounding this number to the nearest tenth, I'm going to look at my place value. Well, this is my tenths place. This is my hundreds place. Remember, if I want to go to the tenths place, I look at the number to the right. If this number is 5, 6, 7, 8, 9, I'm going to go back and I'm going to add 1 to the 3. So when I round this to the tenths place, it's actually going to become 106 point. I add 1 to the 3 because that's larger than 5. 5, 6, 7, 8, 9, and go back and add 1. It's going to become 106 point, add 1 to the 3, 4. So if I round this, it's going to be 106.4 to the tenths place. Now, go back and read the question. How high on the building will the ladder reach? Well, the distance from here to here is 106.4 feet. But remember, it's 8 feet from the ground to where the ladder starts. So I need to include this 8 feet for how far the ladder will go up. So I'm going to include this 8 feet. If you put the 8 here, epic fail, Miami Heat like for you, because you forgot that that's like 8.0. So you just type it in on your calculator. And when you do that, it gives you 114.4 feet. How high will the ladder reach? It will reach 114.4 feet on the building. Hopefully, if you're in this building and you had to get down, you're not higher than 114.4 feet. All right, just a quick review of rounding. And most of the problems in this lesson, they're going to ask you to round to the tenths place. So I'm going to go back to the answer I had before. Let's say the answer you had before was 106.4329881. Just pretend. I know it wasn't, but pretend. If I'm rounding this to the tenths place, here's my tenths place, here's my hundredths place. I'm going to look at the hundredths place. I'm going to ask myself, is this number 1, 2, 3, 4? Yes, it is. So if this number is 1, 2, 3, 4, leave it as it was before. So it does not round up. When you round it, it's going to round to 106.4. Why? Because the number to the right is 1, 2, 3, or 4. In this case, it's 3. All right. Let's pretend that you had 106.49872. I know you didn't, but just pretend. If you're rounding it to the tenths place, here's your tenths place, here's your hundredths place. I'm going to look at the number in the hundredths place. If the number in the hundredths place is 5, 6, 7, 8, 9, you're going to move it up the number line. If this is 5, 6, 7, 8, 9, move it up the number line. So since this is greater than 5, I'm actually going to round this to 106.5. All right? Most of you are not cub-like when it comes to rounding, which is a good thing. You're probably Yankee-like, even though it pains me to say that. But just wanted to make sure you were all not cub-like when it comes to rounding. All right, 2 more examples. I promise these will be the last 2 examples, so Mr. Phillips can go watch Game 2 of the Eastern Conference Finals between the Miami Heat and Chicago Bulls, and hopefully the Bulls get big tonight. They want me to identify or tell whether the given triangle is a right triangle. So first thing I'm going to do, I'm going to label my leg, and my hippopotamus. I am pretty sure that that is a right angle, or 90 degrees, so from diagonal from it would be your hippopotamus. Now, since you have all 3 sides, and you're not looking for a missing side, you just need to plug and chug, put all the numbers in, and see if it works. So, let's see if it works. I have a squared plus b squared equals c squared. Remember, for your legs, you can call either one of them A or B, so I'm just going to say this is A, this is B, plus 10 for your group because you said that your hippopotamus always has to be C. So, excuse me, I'm going to square 41. That means 41 times 41, which gives you 1,681. So C is going to be 1,681. I'm going to square 9. Easy pleasy. That gives me 81. I'm calling this leg B. That's going to be 81. I'm going to square 40. A little bit of mental math. 4 times 4 is 16. Add 2 zeros plus 10 bears for the mental math. And I'm going to say that A is 1,600. Okay. Now, I want to know if this is a true right triangle. So, I'm going to add 1,681. When I do that, that gives me 1,681. Well, bam. How about that? On the other side, I have 1,681. So, since these two are equal, or they're the same number, 1681 and 1681 are the same number, yes, this is a right triangle. Excellent job. Plus 10 for your group because you were thinking. And what you said was, well, if they're the same number, then yes, it's a right triangle. But if these two are not the same number, then it's not a right triangle. Excellent job. Plus 20 for your group. I have absolutely no idea how many points you have. But hopefully, LeBron James and D. Wade don't have as many points as you do. It's okay if D. Rose does, though. Alrighty. Tell whether the given triangle is a right triangle. I'm going to assume that this is a right angle, but I am not 100% sure. This is obviously not a right angle. This is obviously not a right angle. I'm thinking those are acute angles, plus 10 bears. So, since I think that this is a right angle, I'm going to say that this is my hypotenuse, which is always letter C. This is my leg. I'm going to call it A. This is my leg. I'm going to call it B. You could have called this B, and you could have called this A. Plus 10, commutative property. So, I'm going to take 24. And I'm going to square it, which means 24 times 24. Bada bing, bada boom. Gives you 576. So let's write our formula. A squared plus B squared equals C squared. So plug and chug. C is going to be 576. I'm going to square 18. 18 times 18, 324. I'm going to plug and chug, substitute. Ooh, plus 10 bears. I'm going to plug, substitute 324 for A. I'm going to square 12 12 times 12 is 144. I'm going to substitute 144 for B. Now, I'm just going to finish my expression and see if they come out to be the same number. I'm going to add 324 and 144. And when I add them, I get 468. I was looking for 576. Since these are not the same number, by definition, they are not equal. Since they are not equal, this is not a right triangle. If you get to the end and they're not the same number, then by definition they're not equal. If they're not equal, this is not a right triangle. So here, why it might look like 90 degrees, it's not quite 90 degrees. And likewise, you may have a problem where you say, well, I definitely know that's 90 degrees. Well, to check it and make sure that it really is 90 degrees, you need to work out the Pythagorean theorem, because why this does look like 90 degrees, I am 100% sure it's 90 degrees, because when I worked out the Pythagorean theorem in the last problem, I came down to the same number, which means, yes, it is the Pythagorean theorem. Alrighty. Hope you enjoyed our Chicago Bull-like podcast on lesson 6.5. Hopefully, after tonight's game, there'll be another Chicago Bull-like podcast on lesson 7.1, measures of central tendency, mean, median, mode, range. I'm thinking we might be able to do a nice lesson on the mean average of how many points D. Rose scores in tonight's game. Or we could do the mode on the number of rebounds the Chicago Bulls have tonight. Ooh, good idea. Plus 10 Bears. See ya. Go Bulls.